All right, we're going to look at a couple different operations on functions. So to do that, we're going to use two functions as our examples. F of x equals x squared plus 6x minus 7, and g of x equals x minus 1. So using these two functions as our examples, we're going to look at the addition of these two functions, subtraction of these two functions, multiplication, and of course, division. When we add two functions, all we're doing is basically combining like terms. So here we only have one x squared term, but we do want to combine our 6x and our 1x. That's going to give us 7x. And then we have minus 7 and minus 1, which will give us negative 8. And so this is our full answer. When we subtract two functions, we're basically going to do the same thing with combining like terms, except it's important to make sure you put the first one in front. And then don't forget that you need to distribute this negative sign to both of the terms in the second function. So this is going to give us x squared plus 6x minus 7 minus x plus 1 because of that distribution. And now we can combine like terms. Again, only one x squared term, and then we have 6x minus x and minus 7 plus 1. So x squared plus 5x minus 6 is our final answer here. Now with multiplication, it's important that we remember to use the FOIL technique. And even though our first function has more than two terms, we can still apply the same process. So we're going to take our first term, x squared, and multiply that by our first term in g of x, and that's going to give us x cubed. And then we're going to multiply that by minus 1. Then we're going to repeat the process with 6x, multiplying it by x, and then minus 1. So we get plus 6x squared minus 6x. And then lastly, we're going to do that same thing with negative 7, multiplying first by x, and then by negative 1. Now that we're done foiling, we can go ahead and combine like terms like we have with the other operations. So we only have one x cubed term, so it's going to stay by itself. Then we can combine the minus x squared plus 6x squared, which is going to give us plus 5x squared. And then we can combine negative 6x and negative 7x, giving us negative 13x, and then our constant plus 7. So this right here is our final answer because we cannot simplify it any further. Now, finally, for division, we want to set that up with our first function on the top and our second function on the bottom in the denominator. In this case, we can actually factor the top into x minus 1 and x plus 7, which allows us to cancel out our numerator. And that leaves us with just x plus 7 as our answer. However, you won't always be able to cancel out anything from the top and the bottom. So I'm going to show you what that looks like when you can't do that. So let's say you have something like f of x is equal to 6x plus 2, and g of x is equal to 4x minus 2. Let's see what that would look like when we divide f by g. So we want 6x plus 2 in the numerator and 4x minus 2 in the denominator. Now notice we can pull a 2 out of both of these, and those 2's will cancel out, leaving us with 3x plus 1 over 2x minus 1, which we can't simplify any further, so this is our final answer. However, we can't have division by 0 and at any point, so our answer is going to include all of the values of x except for the ones that make the denominator 0. So we don't want our denominator to be equal to 0, so we have to exclude the value of x that would make it 0. So the way that we can determine that value is by setting our denominator equal to 0 and then solving for x. So we get x equals 1/2, which means that if we were to plug in x equals 1/2, our denominator would be 0, which is undefined. So our answer must exclude x equals 1/2. So x cannot be equal to 1/2. But here's our answer, and you have to include that exclusion. So there we have addition, subtraction, multiplication, and division. Next, we're going to talk about what we call function composition. So when we compose two functions, let's say again we have f of x equals, let's do new examples, 3x plus 1, and we'll say g of x is equal to x minus 5. When we compose functions, and this is what that's going to look like, either f of g of x or g of f of x, what we're doing is we're taking the function that's in the parentheses here and we're plugging that in for x into the first function. So in this case, f of g of x would look something like this. We have f, which is 3x plus 1, and we're composing it with g of x. So instead, we're going to replace the x with the entire g of x function. Once we've plugged in the function g of x, we can then evaluate this. So in this case, that means distributing the 3 to both the x and the 5. We get 3x minus 15 plus 1, and then we'll combine the like terms, 3x minus 14, and that is our final answer for f of g of x. To find g of f of x, we're going to do basically the same thing, except this time we are plugging in f of x, which is 3x plus 1, into x in the function g of x. So we have g of x is equal to x minus 5. Instead of x, we're going to write 3x plus 1, because that is what f of x is equal to. And then we can't forget the minus 5. Here we just want to simplify. We don't have anything to distribute. We can just go right ahead and add like terms. That's going to give us 3x minus 4. So 3x minus 4 is equal to g of f of x. And that's what it looks like to compose functions.